to another episode of Tradecraft. This week, we're returning after a 1-week break. We apologize about that, but sometimes it takes a little bit more time to get a good episode together, right? We're also going to be featuring some new screen sharing capabilities added to Blab. So, what Casey Smith coined the Squiblydoo attack, which is more or less a way to leverage Windows built-in COM Scriplets or XML scriptlets and the Regsvr32 process to be able to give you kind of a fileless persistence, a technique to bypass whitelisting, for instance, like app locker, and even a way that helps you get around some of AV products that are specifically looking for trusted and untrusted executables. So with that said, we begin every episode with just kind of an overview. We do this almost every Tuesday at noon, considering that we missed our episode last week. It's noon Eastern time. We're available both through the Blab platform and directly through the library webpage as well. And what this does is Blab allows you guys to be interactive. The whole point is not for us to be able to speak down to you like a conference. It's for a conversation. So with that said, you can join us. You click, hey, I want to chat. You can jump on the webcam and actually go interactive with us or ask your questions from the prompt. With that said, we'd love to hear your guys' ideas. Feel free to hit us up on Twitter at Tradecraft Tuesday. And with that said, I'm Kyle Hansloven, and this handsome devil here is Chris Bisnet.
So like Kyle said, I was just going to say, we try to make this less formal, not like a podcast or a video podcast where we're like, here's what it is. We created this with the idea that people would jump in and ask questions, say stuff. So if you have any questions, definitely jump in.
Absolutely. So we begin each episode with kind of news. Just to reiterate, Chris and I actually were honored to be accepted to teach another class at Black Hat this year. We're going to be teaching fuzzing for vulnerabilities. It's a 2-day class. And it happens, Chris, you remember, is it the last couple last days of July and first days of August? Yeah,
so it's a 2-day training. We're giving it twice, July 30th and 31st, and then a new one on August 1st and August 2nd. And then the Black Hat Conference starts on August 3rd. So depending on how they fill up, right now the August 1st to 2nd class is filling up more. If the July 30th and 31st class doesn't fill up, they might cancel it. But you have about 3.5 weeks left for early registration, which saves you about $200. Some interesting stuff. The other day, Kyle tweeted, was that yesterday? I think was that yesterday or Sunday? I think it was yesterday.
Yeah, something like that.
Kyle tweeted out a link to a crash that we found in QuickTime. We found this when we created the class. It's one of the first fuzzers you learn how to write. It's still a 0-day in QuickTime. It's not weaponized or anything. You basically play the movie and QuickTime will crash. So all the students who come to the class, they basically learn how to write a fuzzer that will do that. So if you're interested in finding bugs, or if you write software and you would like that software to be more secure, you want to learn how to fuzz it, definitely come take our class and we'll show you what we know.
All right, but enough shameless self-plugging, right? There is more exciting news going on. And a good one of these is, just wanting to learn, we're seeing a more and more interest of folks wanting to learn how to analyze malware, specifically younger folk coming straight out of high school or even college, jumping straight into it. And so we found a really great article, which is kind of like the beginner's guide to malware analysis, and wanted to share that with everybody here. The article kind of gives an idea of some tools. It walks through PE Studio, which is a fantastic piece of free software. I highly encourage you guys check it out. On top of it, going a little bit further, we talk about malware a lot in here. Even today's topic is kind of pseudo malware-ish, and we noticed that some older malware has been using new tricks this week. Specifically, McAfee was reporting on, I think it was Dynamer. Was that it, Chris?
Dynamer,
that was using new technique.
Yeah, I guess it's like it's been around for a while, but it's been updated with some I wouldn't say new techniques. These techniques kind of been around for a while, but it leveraged them to basically hide itself from tools. So if anybody's not familiar, there's a something in Windows like a little tweak, I guess is what they call it, called God mode, where you can make a folder and you put this extension on it, which is like a class ID, COM. And what Windows will do is treat that as a special folder, and it will basically link to a bunch of control panel stuff. And then they combine that with another technique where if a folder is named something like COM4, COM1, COM2, Explorer treats it as a device, not as a folder. So basically what happened is they dropped their malware in there. Normal tools couldn't see it because it's a special folder. And even once you did find it, it was difficult to delete because Explorer was like, you can't delete a device. What are you doing? So
yeah, that's a really neat piece of tradecraft there.
Yeah, so there's some instructions in that article that, if you have this, if you find you have this, they show you how to remove it. It's a really simple command line thing, but yeah, kind of interesting.
Alrighty. In other news, I think I saw a whole bunch of Android malware. Sadly, new malware using same old terrible tricks. We cover some of this on the show here, talking about, hey, look how this malware is taking a look at your call logs, browser history. Some of those are specific to mobile, but the idea behind Android malware doesn't appear to be going anywhere this week.
It's terrible.
Same old stuff.
No, if you're an Android user, do not enable software installing from untrusted third-party sources. Do not do it. I don't care what they tell you you're about to get. I don't care if you think you're about to get all the apps for free. It's a terrible idea. That's how you get malware.
Yeah, I agree. Alrighty, and I think the final interesting thing we saw in the kind of hacker tradecraft malware news was a pretty funny story. Yeah, a Russian malware creator. He got sentenced this week, and I think it was almost a $7 million. This guy. I guess the terrible word to the wise would be, don't travel to the U.S. for a conference if you're like an international criminal / malware author. Yeah, just stay in Russia. Just don't come to where people want to put you in jail. Like that blows my mind. Fair enough. So that kind of wraps it up for this week's interesting news in regards to malware. And we're going to jump right now into kind of the technical stuff, the reason that you came here. So for those that aren't familiar with the Squiblydoo attack, the idea behind it is folks are constantly looking for new exciting ways to execute code. And it's not just necessarily initial code execution that matters. It's what context is the code being executed in.
And there went Kyle. Well, that was interesting.
Still here.
All right. So basically what we're talking about here, and hopefully Kyle will come back in a second, but we're talking about executing code through what are called COM Scriplets. So usually COM objects are written in like C or C++, and they compile down to a DLL. But in this case, this is a technique where you can actually run code as a COM object, but that code can be in a scripting language, which means you don't have to have a file on disk. Are you back? You made it? Yes, no? Okay, well, we'll keep going. So basically, how they're going to be run is they need to be registered with Windows. So Windows was designed back in the day. This is like really early 90s when they were first putting together Windows. And they said, you know what, we need to have ways for different applications to talk to each other and for applications to expose interfaces for the things that they do. And it would be really nice if you didn't have to rewrite that code a bunch of times. And so that you could, one application could ask another application to do things. And then, so they came up with these COM objects. And they have to be registered with the system because when you want to use a COM object or talk to it, you have to know what's called its class ID, which is this long UUID-like number. So the way that you register these is through an application called RegSvr32. So regsvr32 is like a command line utility that you can use to register, unregister COM objects, and it's provided with Windows. It's there by default. It's signed. And so this technique basically utilizes that to gain code execution.
So, Chris, am I back here? Because you got to love live
now.
shows, baby.
You're back now.
Live internet-based shows. So what I missed real quick.
So what you missed is I gave a general overview of COM, the history of it, where it came from, what it's used for, and then we talked about regsvr32 being used to register and unregister COM objects.
Gotcha. So I take it I was mid-sentence when the internet dropped about how the context of execution matters, right? And the reason Chris has given this backstory here is the technique that Casey found specifically leverages essentially RegServer32 and the underlying COM subsystem to execute code that could potentially be malicious within the context of those things, of RegServer32 or the COM subsystem underneath the hood. So the reason this is so darn important, if you think about it from a defensive perspective, application whitelisting was almost the first thing that came to Casey's mind, considering that he is an application whitelisting aficionado. And he said, you know what? I bet I can get code execution here of my own JavaScript, of my own VBScript, and I bet Microsoft or AppLocker specifically is going to run and assume that this is RegServer32, which, by the way, is allowed by AppLocker by default. And so that was some of the path he was going down. So I shared earlier that we can do some screen sharing, and I think it's really exciting here to maybe share a little bit about where Casey went in some of his research methodology, because that's arguably as exciting as the actual technique he ended up finding in the long run as well. So we'll give a quick attempt here to screen share, and if it doesn't work, like it looked like it's not going to. All right, not going to work now. So what I'll do is I'll keep talking, and what that means is Casey went down this path, and I'll share it right now, where he essentially blogged and said, "Hey, I discovered a really sexy way to be able to execute scripting language code, which turned out to be JScript and VBS, but I can do it from an XML file." And that's what we mean by these COM scriptlets or XML scriptlets. So it's essentially a plain text XML file that you could give it and slam in a section that says, here's the scripting code, run this when you register. And that's super powerful, right? The obvious reason of like, oh, hey, this is going to be running from the context of a Microsoft signed binary that's trusted is dangerous enough.
Right.
But he didn't just stop there. I mean, he declared victory. Hey, I passed application whitelisting there. But what's so exciting about the research community is, with some nudges and some people doing some suggestions and just some ingenuity on his own, he said, hey, you know what? Not only can I run this scriptlet file, which usually ends in a .sct extension, well, let's see if I can run it with any extension. Does the extension even matter? Because all of Microsoft's examples said, hey, it needs to end in a .sct extension. And he found out, voila, I'm able to run this code, and it doesn't matter what the extension is. So now that becomes even more dangerous, right? You could send something that's just a text file. Nobody thinks, oh, a text file is dangerous. Why do this? And then he took it a step further, and he noticed that one of the fields was essentially a URL provider, which allowed you to specify not just where you want to run this scriptlet from locally. What happens if this scriptlet was, say, hosted on GitHub or on any internet website, on an SMB share, etc.? And he ended up discovering that under the hood, the built-in COM plus subsystem will happily take that URL path. It will happily use the default creds that the proxy settings that are there to be able to establish internet connection, and it will fetch this scriptlet file for you and execute it remotely. Mm-hmm. And that's a big thing. That changes the dynamic from, well, here's an attack that relies on an artifact that must be on disk, and it must be kind of a post-exploitation technique, to a whole nother level where you can maybe even use this as a terrible phishing scheme of like, hey, open your command prompt and from an elevated prompt, type this command in. And we're probably all eye rolling right now that happens, but I've seen effective phishing schemes that involve, here's this password, extract this password protected and encrypted zip file, insert this password, pull out this exe, and now run it with this particular command, and that works. So the fact that he found a one-liner command that can be thrown into an elevated command prompt and give code execution from a server somewhere out there on the internet over HTTPS or over, some SMB share, that's super powerful.
Yeah.
So with that said, we mentioned this is question-based. So, Chris and I will keep chatting about how the technique works, but I strongly suggest if anybody has any questions about like, where can I find this example? Tell me a little bit more about it. Feel free to chime in, like ask the questions with /Q. It definitely makes the conversation way more interactive.
Right. So I guess like the key piece that he found here that was the big win was not just that he could run regsvr32 and then it would run, because by default what would happen is you would run regsvr32 and it would make an entry in the registry saying that if an application requests class ID whatever, give them this DLL or give them this scriptlet. And while that's great and that's cool, he had no way to execute it. To execute that, he would have had to have yet another program that would open that class ID that would then try to do something with it, which means that he couldn't bypass AppLocker. So making a third binary that he would have to put on there wouldn't be signed. AppLocker would say, no way, we're not running this. So one of the things that he found was that you could put code that would get run upon registration or unregistration. And so once he did that, then he could run the command. Then the command, instead of putting anything in the registry, he would tell it to unregister basically a COM object that didn't exist. So that would fail. Then it would call the callback to say, hey, you've been unregistered. And then that's where he could actually execute his code.
So what Chris is saying here, and what you guys probably might have had a hard time understanding, is here's an example of, this is client HTML used. I'll actually find a scriptlet here. Here's a textbook example on how a scriptlet works. And if you take a look here, it's typical XML. It has a scriptlet tag. But Chris is talking about when he said this registration class, is you typically see it here. There's a description, program ID, version class ID. And typically the script gets inserted down here, which is still dangerous in its own. The fact that, you can add a method or you can add this. So upon registration, it will add this and execute this VBScript here. But what he was demonstrating with, some of the code that was updated by Casey was it doesn't have to be inserted into that, that actual section later on in the XML. You could actually throw it in the registration portion. And this is what's highlighted right here. This is straight off Casey's GitHub page. So all of this is public code. And it really drives home the point that, the reason this is so much more dangerous is it doesn't require certain registration. This is kind of what helps enable that fileless execution. And it even minimizes, from what I recall, of the folks that have done the forensics on this from a defensive perspective. I believe the comment was, hey, there's actually significantly less artifacts created in the registry by leveraging the script execution within the registration tag in the XML. Chris, is that your understanding as well?
Yeah, so there's nothing created in the registry. So if you look at that command, you see that command line right there?
Which one are we talking about, Chris?
That one, 3 lines up from your mouse. See that regsvr32? So he specifies the /u there, which is uninstall this COM object. But there is no COM object to uninstall. So if he'd have done install, it would have made it would have added a registry entry to say this COM object with this class ID, use this scriptlet or whatever. But because he said uninstall, it basically fails. The uninstall fails, but then it still calls that callback code that was inside the registration tag.
So we received one interesting question, which was, can anyone confirm if regsvr32 will work with HTTPS? And
I can confirm that. It does support TLS.
That's absolutely right. So if you think about it, not only are you pulling across this, JScript or this VBScript to execute, you're pulling it over an encrypted channel, which is using your native proxy settings on your box. So it's proxy aware, as Zone just pointed out. It's a nasty combination of things. Ideal for an attacker, nasty for the defender, right? One of these things that we didn't talk about, and I kind of blew through, is a lot of folks have assumed that the nasty culprit behind this is RegServer32. And yes, RegServer32 is one of the reasons that it bypasses application whitelisting, because typically AppLocker, out of the default settings, it allows RegServer32 to run because it is a trusted file. It's used by lots of third-party and internal Microsoft features. But what's really doing the heavy lifting here, and it's kind of the client interface to this code, is this scrobj.dll, and that's really what's doing some of the parsing and the processing. So if you were to spend any reversing time here and taking a look of where the actual execution is coming from, here's your culprit. It's the Microsoft DLL scrobj.dll.
Yep. Did you see that class ID he put in there?
I see feed ACDC. I think that's friggin' awesome. So, and we take a look here. I mean, there's plenty of code here, and I won't beat anybody over the head. Casey's done plenty of great examples on how this can be used to bypass application whitelisting. On top of it, he made a very simple client and server that executes back and forth. I'll paste it right now into the chat in case folks haven't actually followed along or aren't familiar with the code that he's done. And furthermore, I really enjoyed, ironically, when I tried to translate who the author of this was, it said good student. Nice. So I'm not quite sure who good student or virus tracker is, but there's a fantastic now English translated article here, which walks through a lot of Casey's research, but it's a very graphical, explanation. And it walks through, hey, here's Casey discovering some of the file persistence initially. They walk through what is RegServ32, how it works, a lot of the subsystems that we've talked about. To be honest, we've borrowed a lot of, some of the ideas for this show straight off this blog because it was such a great example of how things work. Here's the components.sct that we talked about. This is a good proof of concept, as well as there's the simple command that was initially published saying, hey, here's RegServer32, give it the scriptlet, and give it the DLL essentially to register with. What's interesting is this is where Casey came through and realized that you could provide that HTTPS URL here. And at one time, Casey was posting a GitHub, example of how to run this script directly off his GitHub blog, which he ironically followed up with like, why are you guys running this code? Hopefully it was within a VM, but obviously you should just trust it. So Zone, I missed your question here, but it looks like, so you still need some mechanism to call RegServer32. Absolutely right. You still need something to interface with COM, but if you think about it, RegServer32 is doing nothing more than calling Win32 and COM APIs under the hood. So it would probably take Chris and I about 2 hours to pull apart RegServer32, find out what's happening in this particular branch, and re-implement essentially the API calls that are being done in RegServer32 to be able to execute that code. Albeit, that would only get me persistence and remote execution by pulling that SCT file off the internet, and it wouldn't give me an application whitelisting bypass. So there's still a very good reason to consider why RegServer32 should be locked down, should be monitored, why it should not have internet access. But that kind of hopefully explains a little bit why I think both you should be aware of what RegServer32 is doing, at the same time why it's not necessarily the bee's knees, and you need to consider more than that as well.
So Zoned asked a question about this isn't actually persistence, it's a whitelisting, application whitelisting bypass. Like how would you kick this off again after reboot? Gotcha.
So there's some stuff that hasn't been essentially explained in depth, but I think with some of the registration, you could essentially, if I recall what Casey was doing, was he was using the same technique that we exposed in some of the PowerLix malware, which was using JScript by default. And so he was actually persisting, the call using mshtml.dll to run JavaScript fileless. in which it could be used to pull down, this SCT. So I believe that was his intention there with the persistence mechanisms that I saw.
You could also add this just as a generic registry key, right? Put it in the run, have it run every time.
Yeah, I think that was Casey's example. It was just a good old-fashioned run key that kicked off, his JavaScript. But there's 10 different ways to skin this cat of how you get that initial momentum. All right, I'm flying through here. You guys can live see me scrolling. The point behind this article, which I'll now paste one last time, is there's a lot of here to learn. And there's a lot of, functionality that I've kind of glazed over for the sake of a 20, 30-minute episode.
Right.
But one of the important pieces I haven't seen too many people look at, I saw a lot of folks say, like, guess what, Kyle, you can get past application whitelisting. But I've got a lot of experience testing security products and validating their functionality. And I can attest to the ability that there is a significant amount of AV products who would essentially detect functionality traditionally, but when ran through the context of RegServer32 and using scr.obj.dll, that it gets past those. So it's a prime bypass for kind of like your endpoint security products, AV products as well.
Mm-hmm.
So we're running a little low on time, Chris, and I know we've kind of gone a little bit off track as some of the questions have come up, but I kind of want to talk a little bit about defense, right? It's something that we always kind of leave out in our show a little bit, or we say, in this particular scenario, this issue is bad, you're screwed.
Yeah.
So what's neat is the guys from Bleeping Computer played around. And I noticed there was a lot of comments. I'll give the initial credit to Lawrence Abrams from Bleeping Computer. But essentially, they pulled apart the same Tradecraft and said, you know what happens if ransomware wanted to use this exact same technique, specifically because there's several variants of ransomware that are JScript based by themselves. And he pretty much said, hey, without a whole lot of time and expertise, you could actually retool some of this ransomware and make it run with the same technique. And we should be, worried.
Mm-hmm.
It even includes, sexy video here. If you guys are interested, I just posted a link. But what was interesting about it is he was one of the, I won't say one of the first, but he actually said, hey, you know what? There is no reason under the sun that RegServer32 needs to be making outbound requests. And I think that's a very safe, bet. Maybe there's some stuff, for instance, that's using this legitimate functionality. But my argument is, considering that this technique was added in the 1999 to be able to use these COM Scriplets and hasn't gained much traction since, I'm willing to bet you're probably safe by adding a firewall rule. And if we take a look here in this blog, that's exactly what he walks you through and saying, hey, you want to create yourself some outbound rules that say, why in the world should RegServer32 ever need to communicate on outbound ports, blocking the connection. Furthermore, something I didn't want to skip here was in the comments. People said, hey, that's sexy how you gave the UI rules, but McMod here threw in a rule that said, here we go. Here's the command line syntax. If you want to be able to implement this right away to block RegServ32 and both the 32 and 64-bit versions of the executables so they can't reach out. I think that's a very good step in the right direction. That's probably should be tested, but my guess is it's probably minimal.
Yeah. Awesome.
So, Chris, we flew through this. I guess we can, leave it open for some questions here real quick. Chris and I will do some of our outro. If anybody has any comments, looks like Matt just had threw something in here as well. I think it was using emit, right? Even better.
Yep.
So I'll bring this up on the screen right now. Here's another reason to use emit. Microsoft's essentially exploit mitigation tool, and says, hey, here's a nice, simple, easy way to be able to block it using emit. If you're not using emit, you probably should be. Thanks for that, Matt. That's pretty slick, man. I saw that this morning and completely spaced on it. If we take a look, I think the result is, hey, not only do you know about it, you're going to get event logs that you could correlate and be able to parse what's actually going on, what's the attack surface like, etc.
Nice.
Here we go. ASR mitigation in Regsvr32. So that's a fantastic use of existing technology.
Did you see that came from IAD?
Yeah, I saw that.
Very nice. They're not all evil.
No. See, I actually, you know what? I think I saw Matt's comment earlier that says, "Hey, every now and then the government does deliver something that's, contributes to the welfare of of all." So, thanks, NSA. Oh goodness. Alrighty, Chris. I'm gonna stop the screen sharing now. I think that's a pretty cool use of screen sharing. Hopefully, you guys got a kick out of it. Let us know what you think.
Yeah.
All right. I'm going to sign off now, Chris, unless you have an issue.
No.
All right, guys.
I think we pretty much covered it.
Thank you again. I'm Kyle Hansloven. This is Chris Bisnett. It's been an excellent episode of Tradecraft Tuesday. You can catch us live here noon every Tuesday. And whether you find us here on Blab or Cybrary, stay tuned. Also worth plugging, I heard some big announcements coming on Cybrary later today. Definitely take a look at it.
Nice.
All right, guys. Have a good one.
See you next week.